given that the function f of x is equal to x squared minus 4 and g of x is equal to x plus 2, find each of the following algebraic operations. So here we have 4 parts. We're looking for the sum of f plus g. We're looking for the difference of g minus f. We're looking for the product of g times g. And last but not least, we're looking for the quotient f by g. So for part A, we want to recall how we expand this sum out to take the sum of our 2 functions. So we have f of x plus g of x, and plugging in our given functions, we can rewrite this sum as x squared minus 4 plus g of x, which is x plus 2. Now notice here we have 2 like terms, our constants, -4 and 2. So to simplify, we combine them up, leaving us with the final answer of x squared plus x minus 2. Now in part B, again, begin by recalling with part B the definition for the difference of difference of functions. So we can expand this out to g of x minus f of x. So substituting g of x in, we have x plus 2 minus, and now just be careful here because we're subtracting, let's incorporate brackets or parentheses around the entire f of x function. So minus parentheses x squared minus 4. And those parentheses are there to remind us to take this negative sign and distribute it through to both terms. So we can rewrite this now as x plus 2 minus x squared. And notice a negative times a negative is going to leave us with a plus 4. And just like with part A, we can now combine up our 2 constant terms for our final simplified answer of minus x squared plus x, and 2 plus 4 gives us 6. Now in part C, we're looking for the product of function g of x with itself. So we can rewrite this as g of x multiplied by g of x. Or if we want, since we are multiplying the same function together 2 times, we could rewrite this as g of x squared. So now that we've simplified, we can go ahead and substitute the g of x function in and rewrite this as x plus 2 squared. Now, if we wanted to expand this binomial out, because we have the square, we know we can rewrite this as x plus 2 times x plus 2. And we'll use our FOIL method here to expand this binomial product. So notice we have our 2 intermediate terms that are like terms, so we can combine those together in our final answer of x squared plus 4x plus 4. Now in part D, we're asked to find the quotient. So let's begin by recalling how we find the quotient of a function or 2 functions and any special restriction. So let's start by reminding ourselves that the quotient of function f of x by g of x has the additional restrictions that the denominator cannot be equal to 0. So we'll keep this in mind as we start solving here. So finding our quotient of functions, f of x divided by g of x, we can plug our given functions in so that we have x squared minus 4 all divided by x plus 2. Now pause for a cause here. Before we start simplifying, let's keep our domain restriction in mind. So we know that the denominator x plus 2 cannot be equal to 0. So solving for x, we can see that x cannot be equal to -2. And we'll keep this in mind as we simplify. So in the numerator, we have a difference of squares, and we can rewrite this as x plus 2 times x minus 2, all divided by x plus 2. And notice we have matching binomials. So these terms will cancel each other out to 1, leaving us with the simplified quotient, x minus 2. And now for your final answer, don't forget that domain restriction. So this is going to be where x cannot be equal to -2.